Okay, today we're going to talk about factoring a perfect square trinomial. Now, like I just told you guys, factoring in general will work to factor this. We don't really have to see this complex equation here, but it's good if we can recognize this, because further down in this course when we're doing completing the square, we have to be able to recognize what a perfect square trinomial is. Okay, so I'll read this formula out to you. What it's saying is the number here squared and the number here can be squared. So in other words, we can find square roots of the first and last number, and the square roots of those two numbers times 2 will be the middle term. Okay, kind of a hard concept to see. Now when we're factoring, we always look for a common factor first. So I'm going to show you this. This is actually a perfect square trinomial, but first we're going to common factor. What's a common factor here? 2. We take the number 2 out of each of these. So always keep that in mind. We always look the common factor first. That gives us a value of 2. 9x squared minus 12x plus 4. Okay. Now, to be a perfect square trinomial, like we said, we need to be able to find the root of the first and last term. Is there a square root of 9?
Yes.
Yes. So let's do this kind of on the side here. So 9, if we square root, is 3. What about 4?
2.
That's right. We can square root 4 to get 2. Now, these two numbers are important. If we multiply these two and then multiply that by 2, that's what this is saying. Multiply A times C times 2. Is it our middle term? Okay. What's 3 times 2?
6.
Times 2?
12.
12. Okay. So, yes, it is a negative, and we're going to talk about that. So, first of all, whatever is here is going to let us know the term that's going to be in both brackets. So what we can do is we can just square root the first term and the last term, and we'll find our factors to this. So we keep our 2 on the outside. The first term that we square rooted, okay, this term here, this will be the first term in each bracket. So it's 3, and of course we attach an x to it. The number at the end of each bracket will be our 2, and the operation completely depends on the operation of our b. So because this is negative, it's negative 2. So the idea of a perfect square trinomial is essentially when you factor it, the factors are identical. So instead of representing them as 2 separate brackets, we actually represent them as 1. Okay? So, in other words, I would ask you to represent this as 2, 3x minus 2 squared. Okay. No, if it's squared, it'll end up like this, and eventually you'll get that. Now, that is completely new to us. It's different. I'm going to show you that what we've been doing, we'll get the exact same answer. Let's do the exact same question with our factoring, okay? The original question read 18, 24, 8. So 18x squared plus 8. Okay, like we said, we common factored the value of 2 out. We start with the exact same first step. When we factor that out, we left with 9x squared minus 12x plus 4. Okay. From here, you can either use decomposition or find the factors of the first and last terms. Let's do that. Factors of 9 are 1 and 9, 3 and 3. Factors of 4 are 1 and 4, 2 and 2. And we need their products to add up to our b, which is negative 12. I'm going to speed this along. And I'm going to tell you that it's actually going to be these two here.
What?
Okay? And the reason being is because 3 times 2 will give us 6. 3 times 2 will give us 6. And in order for both to be the number 12, they both have to be negative. Correct? What is negative 2 times negative 2? Positive 4. So those work. So these are going to be our factors. So if we want to going about this the way we always factor, we know our first terms will be 3x and 3x. And our last terms will be negative 2 and negative 2. The only extra step we'll have to take from what we've always been doing is when you get 2 brackets that are the same, I would like you to represent it like that. Okay? So that's what a perfect square trinomial is, the first part. But it's whenever you get a trinomial, just factor the way we've always been factoring, and you will end up at the exact same answer.